Okay, it won't hurt to start all over again, but yes, we will start with what is the role of the substantia nigra. So, the role of the substantia nigra is to release dopamine. Dopamine is something that we're going to talk about a lot in this component. So, dopamine is a neurotransmitter, and this neurotransmitter is used by is released by the neurons of the pars compacta. All right, so it's from pars compacta component. And another thing that you should know is that its function is to oil uh, the two uh, parts that we have talked about. So if we talk about the direct pathway, what it does is it actually facilitates. It facilitates or it enhances. So the things that you want to do, what you want, actually happen. Um, so in order for this to happen, or maybe I should tell you what it does in the indirect pathway. Okay. So in the indirect pathway, we see that it inhibits. Now recall that the function of the indirect pathway is to stop the unwanted movement. So why would you want to inhibit stopping the unwanted movement? Yeah? It's like someone says don't, and this is the role of the indirect. And then the role of the substantia nigra is to come in and say, no, don't inhibit. Okay? The role of the indirect is to inhibit. And then this comes in to inhibit the inhibition. Why would that happen? So this happens for several reasons. There are some movements that are known as facilitatory movements. Okay, facilitatory movements are movements that you're not necessarily doing, but they are needed for an activity to occur. For example, you need to keep some of the muscles taut in order for you to carry out certain dances, even though you're not lifting your legs. But there's need for certain muscles to have a stimulation so that you are kept upstanding or that your movement is facilitated. So that is the role. They could not be an entire 100% inhibition. So whatever percentage is allowed by dopamine is there to facilitate. All right. So how does it do this? So the responses are due to different receptors. So you see that in the striatum, you have D1 and D2 receptors. And the D1 receptors found in the striatum are for the direct. So you find that when these are stimulated, you will go through to the direct pathway. And whilst the D2 are stimulated, it will be the indirect pathway. So on D2, it will be inhibitory, whilst on D1, it will be stimulatory. The overall consequence of dopamine release in both cases is really to oil the motor movement. It shouldn't be rigid. You want to do what you want to do, but the things that you don't want to do, yes, they should be inhibited, but you should ensure that there's a facilitation in what you are doing. So the facilitatory movements need to be stimulated. Hence, the slight inhibition of the inhibitor, so to speak. Alright, so we're going to see how this happens in both the direct and the indirect. So let's start with the direct. So this is the direct, that's the cortex. Then you're going to have your striatum, GP, so GP, I, C, striatum. Then you're going to have your substantia nigra there. Then you're going to have your thalamus. So what's going to happen here is you're going to have your cortical striatum coming in with a stimulation, and then you have your GABAergic fibers from the striatum, that's the striatal pallidal, going to our tonic. Okay, these are going to inhibit the tonic pallidothalamo. But what happens is right here, okay, right here you have a secondary stimulation. So these are stimulated even more. So you have a secondary stimulation. So there is even more GABA. Alright? More GABA. There's more GABA, it means that here there will be less GABA. Why would be the, because this is GABAergic as well. So it releases GABA. So if you're going to inhibit it because you're releasing more GABA, because you're now stimulating it by dopamine release, you're going to have less GABA here, much less, and therefore you are even exciting the cortex more by the thalamocortical. Again, I'll go through. So thought, we saw how the initial one was. The initial one was you stimulated the striatum, and then from the striatum there was more GABA. There was GABA released in the GPI. Once there was GABA released, then you were inhibiting this tonic fiber, the pallidothalamo, and once it was inhibited, you now could stimulate the cortex. But in this case, you're now enhancing this. You are even stimulating more the striatal pallidal, so that you have even more GABA here. Once there's more GABA, you are then going to further inhibit the pallidothalamo. Once that happens, there will be more stimulation of the cortex. So that's the role in the direct pathway. So let's see what the role is in the indirect. So in the indirect, you still have your cortex, and you have the striatum, and you have GPI, E, okay, striatum. And then you have your thalamus, but you also have your subthalamus, and then you have your substantia nigra. So remember that the overall thing that you want to do here is to sort of reduce the inhibition. So the final thing that you want to do is to have some facilitatory movement go on. Alright, so you will think, and then there will be stimulation. Okay, once there is stimulation, you will stimulate the striatal pallidal to give us more GABA, and once more GABA is given, you are then going to now inhibit the palido-subthalamus. Once you inhibit those, it means now you're allowing for more glutamate to be released onto the internus. And once there's more glutamate in the internus, you are overly exciting our tonic fibers to release even more GABA. Once more GABA is released, it means that you are now inhibiting the thalamocortical. That is the normal pathway. But what happens now when there's dopamine? So dopamine will come in and it's going to reduce. It's going to inhibit the amount of GABA that is being released in the externa. So once you reduce the GABA here, what is going to happen is now you are like stimulating the palido-subthalamus. Okay, so it means that there will be more GABA released here because you're not inhibiting it that much. So if there's more GABA released here, what will happen is the subthalamus palidos will be more inhibited. Sorry about that. Sorry about that. The subthalamus, let me start again. So you have an inhibition happening here. It means that there will be less GABA that will be released in the GPE. And once there is less GABA there, it means now you are not inhibiting the palido-subthalamus tract as much. So it will release more GABA in the subthalamus. If it's releasing more GABA in the subthalamus, this will imply that it's inhibiting the subthalamus palido tract. So there will be less glutamate here. If there is less glutamate here, it means that you will have less stimulation of the palido-thalamus. If there is less stimulation, it means that it will not release as much GABA. Okay, it will not release as much GABA because you're not stimulating it as much. All right, so it will not release as much GABA. So if it's not releasing as much GABA, it means it is not inhibiting the thalamocorticals as much. So if it's not inhibiting the thalamocorticals as much, it means then there will be some form of activity up here. So if there's some form of activity, then we can have our facilitatory movement taking place. Okay. So let's now look at disease.